We don't live in a world dominated by precision and clear-cut answers. In the real world, it is where the ambiguity strikes. Instead of this, we often rely on binary decisions which are either true or false, black and white, but it doesn't make sense in most cases. But what if we could embrace all shades of grey and really understand things through the essence of human thinking? Welcome to the fascinating world of physiology. Today we are going to look on the basics of physiology, but we will also use one concept that get to my mind before this recording. So we will go to the real life world example through discovering the nature, and then we will look on the mathematical exercise where we will discuss some more things. So first of all, if we have plant, imagine this is a plant, this is a root and all the other things that I cannot name in English, and it's raining. But for the flower, it's very important how much time and how much water she gets from the rain. But if we look at this problem only by the crisp numbers, if it's rained for only 1 minute, it's still true. And but the flower isn't good from only 1 minute's rain. So we need a scale. How much water got the flower from the rain? So if it's rained only 1 minute, it could be like here, like I would say 0.1. But the flower, we need to establish a number where it's equal to 1. And but doesn't mean it is also very suitable for the flower. But we have the scale where we decided what does this number means. And we have better picture on how much water the flower got. So let me show you the mathematical example. Let me clear this all. So we will have let me grab the pen. We will have the domain, the capital D, where we will have 3 cars. Let me name them P, like the Porsche, I don't know, Kia, and I wanted to do period, but it's also P, so fuck it. The third one will be a Renault, and we will also have a Boeing, which isn't car, but let me show you later. So we will have this domain, and we collected data from the brakes, and we will have 2 cars, and the data will tell us it will be self-driving cars, the hour from what we collected the data, and it will also have the automatic brakes, and it will apply these brakes by the distance between our car and the car in front of our car. And if it's closer than 100 meters, it will apply the force to the brake, and the car will slow down or eventually stop. But we don't want to just, if it's under 100 meters, even like suddenly push the brake to the 100 force and car will stop and everybody will be like disappointed in this car and it will like damage the brakes, all the things. So it doesn't, like, why would we do that? So we need the scale. We will have the scale, so the car, if it will be like more closer, the more force will be applied to the brakes. Yeah, you understand it. So let me clear this. So we have this domain and we need a function that will calculate the force we need to apply to the brakes. And the function will be like this on our fuzzy set A, and it will give values 1 minus x this for x's for variables between 100 meters and 0, and it will give 0 force to the brakes for other values, and it will create ordered pairs in our fuzzy set, and our fuzzy set is defined by variables in a domain and also the function, this function, but we need to do some rules for our domain, but because not everything is a car, so we will need to define some predicate symbol. We will define our theorem. The predicate symbol will be P, and it will be named is car, and it will have arity of 1, and also we will have a functional symbol. It will be called distance. I will call it only dist because I don't want to write the whole poem from this, and it will also give arity 1. And let me explain this. The predicate symbol will give a, I would call, a relationship between the variable and something else, and also it will decide if it's true or false. And the functional symbol will give us the value. We will constrain the fuzzy sets by our defined, I would call, functions. Yeah. So it has to be a car. So is car and variable from the domain, and also the distance of the variable what we collected, the value, have to be below 100 meters, and these values will be, these values from the cars above will be stored in the fuzzy set, if I get it right, maybe not, and we will apply the function on the values. Let me imagine that the function on the first, this will be our convention how we will write these values to the fuzzy set, and it has to be finite fuzzy set to write it like this. And so the function that will give our value from 0 to 1 on the first collected value from the power share, it will have the function and the value of it, and also the the data, and we will have the second one, like, let me check what car we ride here. It will be Kia. Okay, I don't know how to ride or what. Kia, and well, same convention, and the third one will be Renault. Yeah, Renault, and also same convention, but we need the values. We calculated where, and we do not include Boeing because it is not a car. So the value we calculated was, the biggest was from the Kia, because it was not 100 but 10 meters from the car in front of it. So no, I don't want to do that. So the function has given us the value of this. The function gives us 1 minus this, so it was 10 meters from the car in front of it, so it gave us value 0.9 for Kia, and the Porsche was, this is the force we need to apply to the automatic brakes right now. Yeah, and the Porsche was 50 meters from the cart in front of the Porsche. Yeah, so we'll apply the same function for this interval, that, and it will give us the value of 0.5 for the Porsche, and the Renault was on the empty road, so there was no cart in front of Renault, so we will have value 0 for Renault. So no force will be applied on the brakes of Renault, and this will be our final result for range values of our fuzzy set. Yeah. In these videos I will show you my progressions in programming and machine learning, and also in math related to these topics. So there will be like plenty of mistakes, but where do you want to learn where not from mistakes, yeah, to understand. So thank you for watching this, and if you notice something wrong, or you have interesting discussion about this topic, let me know in the comments, like, subscribe, everything. Thank you once again, bye.